right, then we're going to look at how you can find the area of a pyramid. All right, so in this case I have a pyramid with me. All right, that's the pyramid. We have a pyramid like that. Okay, a pyramid kind of look like yeah. So now we're finding the area of a pyramid. Yeah, so the area of a pyramid that we have here is giving us the 4 triangles. We have this triangle right here, we have this triangle, we have another triangle right here, and we have another triangle here. Okay, and we have another. Then from these triangles, what we have is a slant height. Okay, we have a slant height that runs from the peak of it up to down here. That makes now a perpendicular line from this line and the line that comes from the peak going down. All right, what I mean is this. So this is a pyramid. So if I spread it or break it down like in Somba, it will come out like this. Okay, if I was to spread it like that. So this is the base. That's the base. I'll call it S. All right, and this base, it is equal, right? Hence it's square base, right? So it is equal. So we have that base. Then we have that slant height that is running from the peak all the way down to where our base is. Okay, and we'll call that our slant height, which will be denoted by L. Our slant height. Okay, so how do we find the total surface area of this? For us to find the total surface area, we are going to first find the area of this triangle. Okay, the area of this right angle triangle, because of the slanting making us a 90, and that would be 90. Again, if we bring in the slanting, this would be 90, that would be 90. So we are going to use the formula. The area of a triangle is equal to half times, in this case we'll say S times Z, our slant height, right? Half times Z. If it was a base, would have said half times B times H, which is height. But now we are using S and times L. So this is for 1, but now we have 4. That means we can now say our area of a triangle is equal to 4 times what we have here, which is half times S times L. All right. So these 4 caters for all the areas for this triangle, that triangle, that triangle, that triangle. Then for this square base, all right, how do we find the area of a square base? So the area of a square base will give us area is equal to S squared, because you have S times S, L times B, right? Which is S squared, because you have the same. This length is equal to that length. So we have that. So for us to now find the total surface area, denoted by T, total surface area. For us to find the total surface area, we are going to add the area for this, which is 4 open bracket half times S times L, which is the area of triangles, plus, right, the area of this square base, which is S squared. Then what we are going to have now is, if we multiply this, we are going to say 4 open bracket S times L, SL over 2 plus S squared. Then that 2, 1, that 2 is 2. Then we are going to have 2 SL plus S squared. Then now we are still looking at the total surface area formula. Okay, so the total surface area now is equal to, we can now factor out S, because S is common, so S open bracket 2L plus S. Now this is the formula that you use when you are finding the total surface area of a pyramid that has a square base. All right, so quickly let's look at the question from the papers and see if we can answer it now that we know the formula for the pyramid.